the corporate control of food. Now, many of you might have done a little bit of research or reading on genetically modified seed production and how worldwide this has had an effect on farmers, on small farmers, because often I'm not going to get into it, we don't have time, but sometimes the seeds that are distributed are controlled by these seed producing companies, so that you are not allowed to save your own seed. Instead, you must buy the seed from companies, okay? And you are, of course, then they choose the varieties, the species that you will grow, okay? So seed saving also connects you to the natural world. You get to witness the processes and participate in it. It protects plant biodiversity, again, because you will be developing and or very importantly, preserving heritage varieties. And certainly it improves your quality of life because you have better pressures and more control over what you are eating or what you are growing or what you are using to build a community for wildlife. So how to start? Okay, these are 1, 2, 3 very basic. This is basically it. Is you collect the seeds, you make sure that they're ready when you collect them. Okay, go and get them. You know where they are. Make sure they're ready. You go get them. Okay, that's number 1. Collect. Okay, number 2 is dry. You make sure they're dry before you store them. Okay, and number 3 is store them. And by storing, I mean you put them away until they're ready to plant, and you keep them safe. So we're going to be talking about a little bit more than just that. We're going to add some details. Okay, so our contents are based on knowing your seed. So I'm going to go over a little bit of, your grade 8 or grade 10 biology, and in case you don't remember, way back then, when you, and some people might be talking to experts, I'm sure, so this will be something you know already, but I thought a little review would be good. Something about timing, and then we'll talk in more detail about gathering up the seeds, how to clean it and drying it, labeling it, and storing. Another seed, we'll talk about seed types, pollination, and of course, selecting seed. These are all huge topics. I could be talking for days on each of these topics. I'm just going to touch on very, very basic concepts. So first, the seeds are, of course, they're a little different. Dispersal is a very big determinant in how the seeds are formed and how they have evolved. So we have wind, and some of the earliest seeds, all of the angiosperms, which are the evergreens, the gymnosperms, the evergreens, were dispersed by wind. Okay, but in addition, some of the flowering plants, the angiosperms, also are dispersed by wind, and those usually have some kind of structure that will catch the wind and help the seed to fly away. And there's milkweed, maple keys right here with the little wings on them, dandelions, and they all have full parachute type structures. Most grasses are dispersed by wind. Those seeds are dispersed, and they also are pollinated by wind. Okay, so water also disperses seeds, and typically there's your palm tree, and the big palm tree seed floats away, goes bobbing away from one tropical island to the next, very, very cleverly, very buoyant. Okay, water lilies, plants that grow in water, lotuses, okay, all over the world, those seeds are washed and dispersed by water. Animals and birds, and of course pollinators, for example, will carry a seed from one place to another. So the little squirrels, the birds, normally they eat the seeds and they then poop it out, and it's got a little bit of fertilizer there and to help it to grow. The squirrels, of course, will bury their nuts and any other good cache of seeds that they find in fruit seeds. Okay, so seeds can burst open. They're called projectile structures. This is, of course, all of the our geraniums or wild geraniums will do this, witch hazel does this, but then jewelweed and, of course, okra, and there's some pea-type species that do this too. Okay, so genetic adaptation based on, of course, climate and the structure of the land, your geology, your soil types, your geography, but also competition from other forces within the environment, natural forces, and your other plants competing for the vehicles or animals that will disperse your seeds. They develop plants develop all kinds of interesting ways to take their seed away from them. Ants, for example, will carry the seeds away from woodland plants. Okay? Ecological function of the seed, how many seeds does the plant produce, whether the seeds should be near the parent plant or whether it should be far from the parent plant, how is it going to grow best, what ecological services is going to fulfill. Okay, so this is all a very complex and very fascinating field of study. 86% of the world's current living plants make flowers. 17% are pollinated by wind, and that includes many of the tree species and grass species. And we're talking about flowering plants, right? Okay, we're not talking about the mosses and ferns. The majority of the rest are pollinated by insects, and that's why bees in particular are major pollinators, and that is why their bee well-being is right now of supreme importance, and we should all be doing everything we can to help sustain our bee populations, and in particular our native bee populations. So this is a bee that's covered with pollen, and it's on a native purple coneflower. It's on the flowers. This is a composite flower. These flowers have available pollen. Every time the bee flies from flower to flower, and it is pollinating all those little flowers that are in the middle of the cone. Okay, very, very effective, efficient pollinators. Pollinator plants co-evolved. They evolved at the same time. Our first pollinators were beetles, and they evolved at about the same time that our first flowers, which were from the magnolia family, evolved. Slowly, bees evolved from beetles, and away we go in terms of adaptation, the marvelous world of the adaptation of pollinators and flowers and how they serve each other. So this happened during the Cretaceous, okay, millions of years ago. This maximizes the chance of pollination. It increases biodiversity. It works. It's not at random like wind is, although we still have some flowering plants that are pollinated by wind. They are in the minority. The self-pollination, two types of pollination, basic types. These are divided into subtypes, of course, but you need to know the basic types. One is called self-pollination, where you have the male and female parts of the reproductive organs of the flower which is the stigma and the anther. Okay, so you have the pollen comes loose from these little top parts, which hold the pollen of the male, and then the pollen grains sticks to the pistil, which is the ovary organ in the female part of the flower structure, and so a flower is able to pollinate itself. Okay, whereas cross-pollination means that the flower with its, what did I do? Their flower is able to produce, it might have a male flower and a female flower, but the flower or its pollen matures at a different time within the same flower. These are able to cross-pollinate, so it controls its function so that they do not self-pollinate. Instead, when a bee or another pollinating insect visits it, it accumulates pollen, flies over to a different flower, and then the other flower is the one that's receptive. Okay, and the way that this works is very interesting too. So adaptations for wind pollination means that usually the flowers are small. They minimize the energy spent on flowers. They maximize the energy in pollen production itself. So the plant doesn't have to attract insects. Instead, it needs to get its pollen out there and dangling in the wind so the slightest breeze can lift up the pollen and carry it away. The pollen grains tend to be very small, and the stigma that holds the pollen are able to, and the anthers that hold the pollen, they hang outside and dangle. The feathery stigma, that is the female part, also is extended out to receive any pollen that's flying through the air. They just wave it all around, okay, and hope that the wind picks it up. And because it's so random, much pollen is produced. In fact, this is the difference between goldenrod and ragweed. When people say they're allergic to goldenrod, no, goldenrod's pollinated by insects. It's got heavy pollen, sticky pollen grains that require insects to spread it. That pollen does not go into the air. Okay, ragweed, in contrast, which grows right next to goldenrod very often and blooms at the same time, is wind pollinated, and it makes pollen very similar to that in the photograph. Okay, huge production of pollen, windborne, that's in the air, and that gets into your nose and makes you sneeze. Okay, so that's the difference. Hopefully, people who are suspicious of goldenrod will not no longer be suspicious of it. It's innocent. Okay, so the results of pollination here, in self-pollination, the offspring are the same as the parents. You don't have any, you're not introducing any new genetic material. So this illustrates self-pollination. Also, the top group of plants, two plants, illustrate self-pollination. So you can have self-pollination from within the same flower, or self-pollination from one flower to another flower in the same plant. Okay, cross-pollination, however, the offspring are different from the parents, because down here in the red, you have a flower of one plant pollinating a flower of an entirely different plant. Now, this is going to be the same species, the same variety of the species, okay, but it's a different plant. So you'll have a different genetic material, okay, there will be genetic differences between one plant and the other plant, and therefore the offspring are combination between the two different plants, and they will be different from their parents. They'll have a little bit of mom in there and a little bit of dad. Okay, so that's the difference between self-pollination and cross-pollination. And okay, so for self-pollinating plants, an example are squash and melons. Tomatoes actually can do both cleverly, and there are other species that that are capable of both. We'll talk about that more in a minute. For cross-pollination, okay, this is really the majority of plants, and you have the different flowers in the same variety. So I'm not going to make a big list, but they're in the majority. Now this is an example of how a flower is able to promote cross-pollination. Even though they have both male and female parts in the same plant, they don't mature at the same time. So this is the throat of a foxglove beard tongue. First of all, the little beard, which is this fuzzy part that sticks out, acts like little hooks. So when an insect, a bee, enters that, they have to give its body a little shake to free themselves from that beard tongue, the tongue that sticks out, and which jiggles the flower and the pollen falls down onto its back. Okay, then it flies away, rolls into another tubular flower, and of course it's covered with the pollen that was shed in the one that it visited previously. So that is a genetic adaptation just to make sure that the bee is covered with the maximum amount of pollen. Okay, so then in the male stage, when the bee enters the flower, the male parts right here are the anthers, okay, and they're covered with pollen, they curve over, okay, and that is where the bees get the pollen, okay. They cannot fertilize self-fertilize because the female part, why does that keep happening? The female part is this little bit right here, this little leap, okay? It's just a little, it goes up and it goes down and then it goes. So this little bit is still immature. It has not yet matured, okay? So then it enters a female stage. The pollen-producing structure, the anther, okay, wither. The female part grows, okay, it's grown longer, so that when the bee enters, hopefully covered with pollen from another blossom, when it enters a flower that has a female stage that's developed, it's going to fertilize. That pollen is going to go into the pollen tube and go into the ovary right here within the female structure. Okay, so they mature at different times, and of course, in a foxglove beard tongue, you have flowers that are at different stages of maturity. So all the flowers are not coming along at the same time, and that is a typical adaptation. And why does the plant, spend all that energy doing this? Okay, well, this is why. So first of all, pollen from a different plant, which is cross-pollination. A typical species are many of your fruit trees, including berries, blackberries and strawberries, your squash, daffodils, tulips, lavender, okay, most of your wildflowers, wind or your grasses, these are all pollinated with cross-pollination. Most of your trees, maple trees, okay, and those are the red maples, we should say. Okay, so this is transferred by wind, insects, water animals, etc. The key thing is that they're brightly colored petals, or they're fragrant. Those flowers are designed to attract the pollinators, whether it be insects or animals. Okay, they have nectar, they have scent, pines and pistils, okay? They have lots of pollen, and they have done as much work as they possibly can to get their pollen out there to a different plant, okay? And the result here is genetic diversity. When you have genes combined from one plant to another, you are adding to the gene pool here, and therefore these, again, the species as a whole becomes more resilient. However, it is dependent on distributing the pollen, and for most of those plants, that it means pollinators. Okay, so pollen from the same plant, if this is self-pollination, then these are some legumes, for example, peanuts. Okay, so orchids, peas, many of your pea family, sunflowers, okay, and then your greens, tomatoes, potatoes, apricots, and peaches. So these are pretty important food families here, okay, and these shed pollen directly onto the stigma. Smaller flowers, think of all the, okay, and they are there's much less pollen. Now, what you get is that you get your offspring is much more uniform. So you have self-pollination, okay, your offspring is going to be very much like, it's going to be exactly like your parent, your single parent. Okay, so hybrid plants are products of crosses between two different varieties, and they combine. So this is cross-pollination, but now rather than using the same type of plant to cross-pollinate, you have crossed different varieties. So this happens within the squash family, and here you have a cross between a grapefruit and a tangerine gives you a tangela. Okay, they're completely new combinations of the good and bad traits from the initial cross. And this is where it gets to be fun, where all the breeders go into action and try to create new species. Okay, so in hybrid plants, if the combination is particularly good, then you generally are much more conscious of which seeds you are choosing, particularly, and you can intentionally cross your plants, the result, the offspring, for specific traits. So this is hybridizing it. And some plants naturally hybridize. For example, the free and lemon maple is a natural hybrid between red maple and sugar and silver maples, and that happens in nature. Columbines will naturally hybridize as well. Here are petunias, commonly found as hybrids, okay, and very often hybrids are not are sterile. So you can affect the genetic potential of the plant. It depends on what you're breeding for. That can affect the viability of the seed it produces. So it then becomes dependent on it will either be sterile or it won't breed true. It will revert back to its original state. Okay, so it's a very involved, discipline, which, of course, is fascinating. And this is where you get plant societies, like daylily societies and orchid societies, that will tell you, where you can share information about breeding. So which seeds shall you save? You can save self-pollinating species, and they will require very little attention before storage. Cross-pollinating species are those that you need to make sure that you keep pure so they don't cross-pollinate. If you want their offspring to be like the ones that you value, we're talking about vegetables here, then you have to take steps to make sure that they're not cross-pollinating with something that is undesirable. For biennial seeds, you will need to keep those plants in good condition because they don't produce seeds until their second year. So here we're talking about vegetables, so self-pollinating tomatoes, peppers, peas, and beans. Cross-pollinating, where there's some challenges where you have to keep the seeds protected, okay, against the undesirables, or squashes and corn in particular, are the classics. And biennials, carrots and beets, take 2 years. So in our handouts at the end of the webinar, I have handout sheets that you can download that will give you information about whether the plant is self-pollinating or needs cross-pollination, and its various parameters for that you need to watch out for when you're saving the seeds. Okay, so seeds from self-pollinated plants, and so these are your beans, lettuce, eggplant, peas, and peppers, and tomatoes. Seeds have the same characteristics as their plants, and now we're talking about heirloom plant varieties because they need to be preserved. We have a shrinking of available tomato species, for example, types. Those that commercial growers can easily produce and ship, but there is a world of tomatoes out there that are heirloom vegetables, that are heritage vegetables, and these are at risk of disappearing because the seeds are more available. So people are trying to preserve these heirloom species, and there's an organization called Seeds of Diversity that lists sources of heirloom species of plants that you can buy, access, and grow. And then you save your own seeds, right? So you get diversity. They are adaptable. They tend to be quite resilient. They're very flavorful. They have a wonderful provenance. The history of the plants is very interesting. And then you become independent of others' decisions of what you should be eating too, which is a good thing. Okay, and so these heirloom vegetables are varieties that were bred by small farmers around the world before they had to worry about choosing varieties that kept for weeks and weeks or shipped well. Okay, and some are prehistoric. So part of the criteria for designating heirloom is some people categorize them as 50 to 100 years old, and others prefer pre-1951 because that's after 1951 is when large production companies came into being. Open pollinated, which means they're not pollinated in a greenhouse or by hand, and they're pollinated naturally in the fields. Non-GMO means non-genetically modified organisms. And this is an example of moneymaker tomato. It was released in 1913 in England, and it was sent to the U.S. in 1963. It is absolutely delicious. I've grown these very, very meaty, flavorful tomatoes. And so you can select if you're growing seed-saving tomatoes. These are the moneymakers, by the way, in this person's hand. They're full ripe, disease-free tomatoes. They're best candidates for seed saving. Now, I should mention this right now, just as an aside, that when you're saving native plant seeds, that you do not select those seeds like you do vegetables, okay? And we'll be talking about that in a few minutes, but this is not a universally applicable criteria when you're saving vegetable seeds versus saving native plants, okay? You want to be able to randomize your selections for natives to allow those natives to develop their own adaptive capacities, whereas in vegetables, you are controlling the growth. This is agriculture here, Mark them with a tag so you don't pick them and eat them by accident, okay? Or no one else does either. So then wait until they are fully ripened, very ripe, pick them off the plant. And you, those ripe seeds, continue to draw some white force from your placenta. This is a ripe cucumber, for example, okay? Normally, you don't ever see a cucumber like this in a store. It would need to be growing on a vine. So you don't harvest it when it's green, which is an unripe cucumber, okay? It needs to be like this. Sometimes they're even darker, gold color, or even brown when seeds are ripe, okay? In a tomato, you'll rinse the tomatoes in water, clean their surface. Before you harvest the seeds, clean off any damaged parts of the fruit, cut them open, and you squeeze them, similar to squeezing an orange or a lemon. Just take the whole thing and just squish it in your hand, okay? Squeeze the juice out, and make sure that if you're using different types of tomatoes, or any type of juicy vegetables like this, that you are keeping them separated so they don't get mixed up. Okay, then the seeds for tomatoes, it's an acid-based plant. You need to ferment it. It ferments quite nicely, and what that does is it breaks the protective casing, the gelatinous material around the seeds. It breaks that down and gets the seed ready for saving. Okay, so you're going to use tomato juice. You don't want to dilute the juice. Don't add water. Okay, label it, and then you set it aside. Generally, it's room temperature for between 1 and 3 days. Usually 3 days works better. Stir a couple of times a day to prevent mold. Now, some people don't mind mold. I have found that it's a lot easier to manage if you stir it and prevent the mold. Okay, and then after 3 days, you will pour off the juice. Okay, you'll decant it into another container. Pour into a larger container. You add 3 times the volume of water. Okay, so you get water and pulp, and then your seeds sink to the bottom. Pour off the pulpy water. The viable tomato seeds will sink, and the not viable seeds will float to the top when you get rid of those. Repeat 2 or 3 times until the seeds are clean. Then you rinse them off. Okay. You've got to use a strainer. Try to get rid of as much of the debris as possible. Flip it over. Smack it on a coffee filter or some kind of paper towel or paper plate. And you want the seeds to dry on that. Okay, label it with the variety name and the date that you harvested it. Okay, so here the seeds are spread out on coffee filters. And then they need to dry in a room for about 7 to 14 days. Make sure you've got a well-ventilated place. You don't want to put them in a closet or inside a cabinet or anything like that. And then as they dry, you want to stir them a little bit with your fingers so that they don't stick. A properly dried seed snaps when it's bent in half, so you can test it. Okay, now these seeds, if they are properly stored, will remain viable for 4 to 6 years. Okay, so that's a good thing. And here's a shortcut you can try: is take the seeds, put them on a little coffee filter like this, little rounds, or little paper towel. Toilet paper, seed discs work. Now these remain viable for 2 years. You let them dry. You can just plant them just like this, okay? And then the material that they're on will just become part of the soil. It will decay. Soil organisms will decay. Okay. And of course, cover them up with some soil. I just was reading yesterday that the Irish tradition and the old farm tradition is just to slice tomatoes and put those on soil and leave them until spring. Just a sliced tomato, cover it up, leave it. And so that would be interesting to try. Okay, so now store your seeds, pack the air dry seeds in small paper packets. envelopes, okay? Label it with the information that you need. Usually that has to do with variety name, collection date, color, and any notes that you would like to leave. And then put them inside little bags. You want to make sure that they do not reabsorb moisture, humidity from the atmosphere. Okay, mason jars are good, pipe fitting lids are good, and store them. So seeds from cross-fertilized plants produce different characteristics than your parent plants, and so you're going to want to isolate those plants when they are in the process of producing seeds. Some distance, a hedge, a group of trees, actually physical distance, okay? But farmers have trouble, of course, if they've got a field of plants that are cross-pollinate. Organic farmers in particular don't want their fields to cross-pollinate with neighboring adjacent farmers that are not organic. And so they need to take steps to make sure that doesn't happen. So they plant a wind barrier around their fields, and sometimes they even bag the heads of their plants that they want to use for seed saving. Okay, so blossom bags are good. That excludes the insects, but it doesn't exclude wind, okay? And hand pollination is easy for corn and squash. Okay, so here's the cornfield, and you can see the paper bags are there covering up, preserving those pollinating the flowers on the plant so that they don't get wind pollinated from any unintentional sources of pollen. So squash are a good example of this. This is a Canada crookneck, the heritage heirloom squash grown by the Iroquois. Now, this is a very good squash. The trouble is that the crooknecks were tended to break in shipping. So these squash were used to as the basis for butternut squash, but you can't buy crookneck squash commercially anymore. But you can get the seeds. So squash bees, these are our native squash bees. They're specialist bees that specialize in pollinating squash. Co-evolved with the squash and gourds from the southern, South America. Migrated north after the ice sheets retreated, and when the squash migrated north, so did the bees. Okay, so we need to make sure that we preserve the squash bee nest, don't till the soil because they're ground nesting bees, and make sure that that you don't spray your squash or use any kind of pesticides around them. Be aware that the squash readily hybridize with nearby. They'll hybridize with melons, which is really interesting, and of course they'll hybridize with other squash. So you'll get all kinds of interesting combinations unless you're careful. And being careful means hand pollinating the squash, which have male and female flowers. And so if you want them true to garden variety and you want to produce offspring, just like the delicious butternut squash in your garden, you want to do butternut squash and save the seeds, you have to make sure that when they are producing pollen, you isolate the squash plant that you want seeds from. Okay, so this is the way the male flower looks and the female flower. What you can do is tie the blossom up. Looks like these reproductive parts are mature. And most of the time, the bee gets there early in the morning and does its pollination thing. So you'd be doing this in the early evening. So you'd be those early waking bees. Okay, and then the next day you can sometimes cut off the petals, which is what this person in the top photo is doing. And he has taken the male flower, has opened up the female flower, and is cross-pollinating that female flower with a male flower from the same plant. Or you can do it with a paintbrush. Okay, so it's fun to try, and it works very well. Of course, has a lot of plants, that would be very labor intensive. Okay, so all offspring are the same varieties would be the result. Collecting seeds from native plants, and we're going to need to speed through this. This is such a big topic that it's hard to get this all done in an hour, but I'll try and speed through this part. So you want to obtain permission wherever you are collecting your seeds from whatever type of landowner. We get our permissions from our Parks and Forestry Department in the city of Mississauga, but then if you're going into somebody else's land, you're going to need permission. Wild versus native. So a native plant is a species that has evolved in a local area as part of this ecological community. This is usually has been in existence in that area before contact, before settlers came. So that's a native plant. Common milkweed is an example. Common goldenrod. But a wild plant may be naturalized. It may have come from local sources, somewhere else. It became established. For example, there's daisies, buttercups, dandelions, Queen Anne's lace. All of those are native plants. Okay. The biodiversity in Ontario is risk. We've lost 98% of our grasslands, and this is why it is very important to create a habitat. Grasslands is the main place where pollinators are depending on their flowering plants to pollinate, for food, for forage. Forests also are very important, and what we want to do is be able to conserve our native plants and grow more, create growth, grow more. It is hard to find locally adapted native plants, and this is why we grow them from seed. And we try to find our seed or get local seed sources, and we get a lot of money. Okay, because it's very hard to find places to buy them, and they're expensive. So if you're out walking around in the field, and you've got permission, you do your scouting, make a note. It's much easier to identify the plants when they're flowering in the middle of the season, and then go back once the seeds are ready and mature. The plant's going to look very different. So you have your notes, maybe you've taken a few photos, and you can go back and find the plant later. Bring an ID book, use a smartphone app, okay, take photos for at-home research. That's always a good idea. iNaturalist is very good app for plant ID. Okay, but sustainable, we don't gather up seeds from rare or endangered species. There are online sources called the vascular plants at risk in Ontario, and depending on where you are living, you would be responsible for researching which plants are at risk and avoid collecting seeds from those. Collect only from common species. So, for example, dense blazing star, something that is often offered in catalogs, native plant catalogs, but if you were to try and gather this in the wild, you would be hard-pressed to find any. They're very, very rare. Certainly, if you found them in the wild, you would never, ever, ever, ever collect their seeds because they are so rare. Okay? And so, for that reason, Blooming Boulevards doesn't plant its blazing star on our boulevards, which is a directive from our local Parks and Forestry Department, because the city workers are not allowed to disturb the plants if they are growing. Okay, they would not be able to repair any infrastructure on the boulevards if they had dense blazing star growing there. So these are just some of the factors. Okay, you can grow it in your front yard. Okay, in your backyard. If you have the seeds, and you would buy them from other suppliers who cultivate these plants commercially, but they are not collecting from wild. Okay, sustainability is no longer about doing less harm, it's about doing more good. So then when you want to go collect your seed and you want to time it right, wait till the seeds ripen. Usually the seeds become hard, dry, and dark. Now this is not, we're not talking about fruits and fleshy plants. Okay, we're talking about field-grown forbs and grasses. Okay, so plants show the signs of dying back right there, especially where the flower part of the plant attaches to the stem. Usually that turns brown. Means that that flower part is finished producing the seeds. The seeds are done. The flower is done. It's ready to break off the plant and disperse. And some seeds may already have dispersed. Okay, so you really have to keep an eye on the plant. I usually go visit the plants I have in mind. I visit them several times just to check the state of their seed maturity. Hot, dry weather can speed up seed maturity. Okay, depends on what your late summer is like. Okay, cool, moist weather can slow it down. And here's a milkweed, and it shows you what's not ready and what is ready. Okay, check your calendar. So usually 2 to 5 weeks after the peak bloom, you have the beginnings of the seeds, the starting seeds start to mature, and you'll have plants that are budding and blooming on the same flowers that are budding and blooming on the same plant, whereas those that have already budded and bloomed have the seeds have been produced, so that can happen on the same plant. And this is New England aster. A lot of asters do this. Measure and weight. There are the seeds. These are the little guys that eat them. Okay, when the seeds are ready, you're going to have birds swooping in and eating those seeds. So be aware if there's seeds that you want to be able to collect, you're going to need to go get them before the birds do. Okay, so oh, I don't have time this weekend. I think we'll go back next weekend. Yeah. Well, maybe. Gather ethically. Okay, conservation's vital. You never would gather if you only have 1 or 2 plants. If it's just a few, you would wait until you found a patch that was significant. And I usually look for abundant 50 to 100 plants. That's when I gather. This would be in the same general area. I take no more than 5% of the seeds that are available. You can go back and visit it several times as those seeds mature. If they've got different rates of maturity, you can go back several times. And if you have several places where the same plant is growing, it's good to space those places, maybe a kilometer or so apart, so that you're not disturbing what that plant is trying to do to preserve itself and spread. You don't want to interfere with that. And you also want to randomize your seed collection so that you're not deciding what grows, the plant decides what to grow. And then plant the seeds and see what happens. Okay, so there's some equipment, tools and equipment, but first you need to make sure that you're safe when you gather. You want to wear a dress for the weather, wear sturdy footwear if you're out in the field somewhere. You don't know what you're going to be stepping on or into. Check for ticks. Places with long grasses can have ticks. You want to wear long pants, tuck them into your socks. Take precautions if you have allergies. Bee stings, for example, they're not very common, but it's not impossible that somebody would get stung. Hopefully not. I've never had that happen. Neither of any of our volunteer seed gatherers, but you never can tell. Anyway, watch out for sharp stems or small thorns too. Okay, so it's just good to be aware, especially if you're taking a group out or out with your family. Then take some of these precautions. Long scissors, any shears for thick stems. Paper bags are very useful. Plastic baggies are useful. An apron with big pockets. These are called blue aprons or kangaroo aprons. Joey aprons sometimes. Notebook and pen so that you can record the information and the name of the species. A camera is also helpful. So this is a joey apron. It allows both hands free. The bottom flips down so that you can just dump your load of goodies. It's good for collecting any kind of plant material, so great for seed gathering. I've got a pattern on how to make your own. You can find sources where to buy these on the internet too. So in our resources that you can download all is the pattern for the jelly apron. So shaking off the seeds off, will minimize that your chafe. Chafe is the debris, the material, that dried material that contains the seeds. And very many times you can just shake the seeds off the plant. Okay, these are columbines, easy to do. You can just break off the whole columbine stem and use it like a magic wand and just sprinkle seeds all over your garden, which is fun. See what comes up. Okay, you cut off the seed head, clean it over later. You take that seed head, put it in a paper bag with some pebbles and shake it vigorously, and the seeds will come out. Grapefruit, bergamot, which is bee balm, and yarrow, coneflowers. Okay, that works really well for those. Okay, so these spring-loaded seed heads, these projectiles, these are all of our crane's bills. Wild geraniums is seeds when they're ripe and ready. You can see this little miracle of plant physics. It goes spraying, the seeds go flying out, and there's the seeds. If you're not careful, the minute you touch the plant, if it's ready to go, the seeds are just going to go spraying, and there's no way you can get them. So people, when they're harvesting these seeds, they'll put them in, before they are completely ripe, they'll put them in a pillowcase, so then it can go springing into the pillowcase, and you'll get the seeds. Then seeds heads, when maturity rate varies within a plant population, so that you can catch the seeds that way. You don't have to go back 3 times a day, look for them. Gather fluffy parachute seeds before they're dispersed by the wind. You can just pluck them off with your fingers. By the way, the little parachute that's a Latin name. It's called pappus, which means old man. Okay, milkweed tips. No need to wait to collect till seeds fluff out. Okay, instead, what you do is just scrape them off the pod like that. Okay, if the pods have opened, it's okay. Try them if they're dry and cracked. You can split them open, do that final splitting before you get all the fluff. Otherwise, it's hard to clean the seeds off the fluff. They break off the fluff, but it's easier this way. Okay, rubber band, the pod will dry, but it's not going to do a dirty trick for a little guy. Okay, so you rubber banded it closed, and then you just open it up and scrape the seeds off. Or you could do it this way: loose milkweed seed will separate from its fluff when placed in a paper bag and shaken vigorously. And I've been gifted with milkweed seeds all loose in a paper bag like this. Okay, what you do is throw some pebbles in there, shake it vigorously, and open up the bag, blow into the bag, and all the fluff will come flying out, and the seeds will be down at the bottom, which is fun. Don't do that indoors. Large amounts of milkweed seeds being defluffed. It's a little defluffing machine. Okay, so dry. You need to dry your seeds. Humidity will deteriorate the seeds. And this is major seed operation here. Spread them out in newspapers. I don't know who would need this major seed operation. I guess if you were seeding a meadow or something like that. Okay. Breezeway, shed garage. This is my seed operation right here. And I have the screens that I use. I've got a variety of trays from the dollar store. I have sieves and colanders from the dollar store. All of these things work well when you're cleaning the seed. And then I just set them out and let them dry, air dry, for a week or 2 weeks. They're in their paper bags. They're never in plastic. I store them in regular paper envelopes labeled, and then I put the envelopes, seal all these up in plastic baggies, and eventually they go into the refrigerator in a big plastic container. Okay, and here's the projectile seed heads in a pillowcase. Okay, so ideas for trays of seeds. You can make your own staple screening, window screening, or any kind of wire screening will work. Little pizza boxes. Okay, So flower heads are dry enough when they feel dry. Probably you want to maximize your ventilation. Try and keep lice and rodents away from your seeds. So you're putting on your seeds, you're removing your chaff, okay? And it's not super important that every speck of chaff is gone, but it saves room, it saves space, and sometimes they tend to mildew a little bit, make things mildew. Okay, so basically you're going to need your screens, sieves, trays, you're going to need some clean paper. You might need a fan. Some people use fans to blow away the chaff. Tweezers, I never use tweezers. Some people do scissors. Okay, handy tools. So if you clean your seeds, you eliminate this bulky pile of chaff, all this debris that's not the seed. It discourages fungal growth, mildews, etc. Clean seeds take up less storage space. They're easier to sow evenly. Okay, so here is somebody with a reasonably, medium-sized operation with a fan, sprinkling the seeds in front of the fan, and theoretically the chaff flies away and the seed that's heavier falls down into the bucket. Okay. The chaff has to be very lightweight for this to work. And this is what I did with mine. I bought these different mesh sizes, use wooden frames. You can use picture frames, Staples mesh, and use that for successive screen seeds. And this works very well. Okay, so you can put the seed heads in a paper bag, give it a few shakes, and put it in a sieve. This works well for round seeds, not for lozenge or angular shaped seeds. Okay, and you can see the seeds that have all these different shapes. So daughter Ben, and blazing star, pearly everlasting, so tiny. Bernarda, Fistullosa, lobelia, or like dust as well. Okay, so all of these have different demands and different criteria for saving these seeds and how you screen them and gather them up and let them dry. You just have to, use your judgment. But I also have a seed guide that that you can download, and that is available online. Okay, so storing the seeds, once they're clean and dry, you want to pack them away. You want to keep them cool. So between somewhere around 7 degrees Celsius or less. Cold basement, garage, refrigerator. Of course, you can control the refrigerator. It's constant, which is what I use. And you want to make sure that each species is stored separately, so you're not going to want to seed mix all together. And then here you go, they're in baggies. They can be in paper envelopes and baggies, and then you put the whole thing in a plastic container that's filled up. Or put them in a mason jar. You can put a desiccant in that jar. And then labeling is very important. Okay, make sure that you've got species and collection date, so that you'll know how old those seeds are, and where you got them is also good. And you can use coin envelopes. You can buy them in bulk, or you can get these print your own DIY envelopes. So summing up, you're going to collect, you're going to dry, you're going to store those seeds. Basically, this is everything you need to know. And we've got a native plant seed gallery that I have downloadable for you. And these are various resources where you can save, or that you can go to. Seeds of Diversity is very good. Seed Savers Exchange is good. Again, North American Native Plant Society, which is also referred to affectionately as NAPS, is a good source for seeds. Wildflower Farm is a place to buy seeds, all of those places. And if anybody has any particular questions, I'm happy to do a Q&A briefly. I know our time is marching on, but if you'd like to take a few minutes for questions, I'm happy to answer questions. This is what we do. Here's our workshop handouts, downloadable right here. Boulevards.org /services.7. And then our upcoming webinar, which is follow-up to this one, it's called Growing Native Plants from Seed, is on the 23rd, and that emphasizes the actual stratification, the cold period, how to do that, and then how to actually propagate the plants. So anybody who's interested in saving its seeds, particularly native plant seeds, would be interested in this workshop. Once it's closed, of course, you can sign up for that on our website. It starts at 10 o'clock and